Okay, so we're going to do section 2.3 today. So we started it, like I said, at the end of last class, which was finding the intersection points between two lines. So we're just going to do a few of those today. So we saw last class the substitution method. So the substitution method is good for solving systems of equations that the equations are written in y equals mx plus b form. So a system of equations means just more than one equation, and in this class we're just going to see two equations. So a system, it just means solving a system means to find the intersection point on two lines. So if you're taking linear algebra, you would see more than two equations and how to solve that using matrices. But in this class, we're just solving two equations, and the substitution method is good if we're given two equations like 2x plus 3 and y equals minus x plus 6, say. So two equations, they're already solved for y, so y equals mx plus b. And to solve or to find the point where those two lines cross, you set them equal to each other. So if we were asked to find the solution, that's the same as asking to find the intersection point. Okay? So you set them equal to each other. And you just solve for x. So if we move that x over and the 3 over, what do we get? Divide both sides by 3. So x is 1. Now that's not the solution. That's the x value of the point, because the solution has to be at both an x and a y. So how do we find the y value? Plug the 1 in to what? To one of the equations. And actually a good check would be plug it into both. You should get the same number because we set them equal to each other. So that's the x value that makes them equal. So find y. So take either equation, like 2x plus 3, and put the 1 in there. So 1, 5. Now, again, that should work like as a check. You could put it into the second question. If you're so inclined to do that. And you'd see you get the same number. So it doesn't matter whichever equation you choose.
So legit just to find y, just like plug in the x value and that always gives you...
Yep. So you solve for x, plug it in, and you get y, and that's the point. So what might we have to do with this? So we found the point of intersection. Probably we would be asked to graph them and to show that. So let's do that. So let's say the question is given those two equations, the same two. So part A might say find the intersection point. Part B might say to graph both equations. Okay, so say this is a question, good test question. So find the intersection point and then graph both equations and indicate both the x and the y intercepts of both equations and the intersection point all on the graph. So A, we found the intersection point was 1, 5. We did that already. So B, if you take our first equation, 2x plus 3, and we want to find the x and y intercepts for that. So the x-intercept, we would let y equal 0. Rearrange it. So that gave you the x value, and remember we plugged in y is 0 to find that, so that's a point, negative 3 over 2, 0. And the y-intercept for that same equation, we let x equal 0. And remember I said you don't really even need to do that because it's just, if it's in y equals mx plus b, it's the 3 right here. But if you don't like memorizing things, plug the 0 in for y, write your point down, plug the 0 in for x, write your point down, you've got your 2 points. And now we need to do the same thing for the second line. Y equals minus x plus 6. So our x-intercept, we let y equal 0. Not much to solve. And then our y-intercept, let x equal 0. And just make sure whenever you do your intercepts, you end it with a point. Because what did I say people do all the time on a test? They forget to write this. Okay, so let me cover up those points. Say you forgot to write those. When you go to graph, you look back at what you did, and you see x equals minus 3 over 2, y equals 3, and you write that as a point. Do you see yourself doing that? So many people do it. So whenever you find your intercepts, write down the point right after. Don't say, oh, I'll remember, because when you look back and you see an x and a y written like that, a lot of people just plot that point, and that's not a point on the graph. It's supposed to be that with a 0 and this with a 0. Okay? So let's draw a graph. We've got all our points. So look at your points and we say, what's 3 over 2? 1.5? Yeah. And can we write that down as 1.5? Or is that rounding it off?
Good.
It's good. Why is it okay? Because it is exactly 1.5. That's not rounding it off. It is 1.5. When can you not do that is when it would be like 0.33333. If it keeps going, if the decimal keeps going and you have to round it off, then that's not accurate anymore. But you can write it if it is exactly something. So that negative 1.5, that's an x value. The other x value we have is a 6. And what was our intersection point? That was 1, 5, so 1. So we need to go down by at least 1.5 and up by 6. So there's 6, 1, 2, so there's our x values. Our y values are 3 and 6 and 5. So if we go up, 1, 2, 3, 4, 5, 6. And I didn't need to put anything here. I didn't have any y values that were negative. Okay, so for our first line, what are the two intercepts? Negative
3 and 3.
Negative 1.5, 0, 1.5, and 0, 3. And the other one, 6, 0, 2, 3, 4, 5, 6, and 0, 6. Now, if you've drawn everything correctly, the point where they cross should be what? 1, 5. And it is 1, 5. Okay. Now, what else do we need to do for full marks here? I said whenever you draw more than one line on a graph, what do you have to do? Label them. So this one is y equals minus x plus 6, and this one is y equals 2x plus 3. You can label it at the top of the line or the bottom of the line, doesn't matter, but just somewhere beside the line you would label that line.
Would there be arrows on those lines?
You can put arrows on the end, yep. Okay. I wouldn't take off marks for no arrows, but it is understood that they do keep going, for sure.
Did you do or you don't take marks off?
I wouldn't take marks off for no arrows, but you do need to make sure it looks like it's going the whole way, like it doesn't stop somewhere.
For the lines,
Right.
well, you have to mark X or Y, you kind of already know that. Like, you know.
No, you already know that. And so here, like this question, I would have said, label the X and Y intercepts, and so I'm looking for those points to be written on the graph. So you're looking for that. So if this were a question on the test, I would be looking that you wrote each of these points down, labeled your lines, and that the lines are drawn big enough that they look like they're still going on forever. Yeah. Was there another question, or we're good?
How did you know it's 1 and 5?
We found that. We found that. Yeah, we found it right here. That was the first thing we did. We found the intersection point. Question 1. Right. I had done this question, and then I said, well, actually, we probably would be asked to graph something like that. So find the intersection point. We already did, and then we found the intercept. Okay. So let's do one of the other methods. So if they're not written in slope y-intercept form, we use what's called elimination. You can rearrange them and use substitution, but the problem is then you get fractions. You have to do common denominators and all that. But elimination avoids using fractions. So method 2 for solving a system. So we use this one if the equations are in, I'm going to call it linear form. Sometimes people will call it standard form, general form, something like that, but I'm just going to say in linear form. It's usually like this. So when you're given an equation of a line, it's usually already in slope y-intercept form, or it's in this form, which is sometimes called standard, sometimes called general, sometimes called normal. So I'm not really giving it a name. Okay, so if they're written in this form, the intercepts are actually easier to find, but the intersection point's harder. Where the other form, the intersection point is easier, but the intercepts are harder. Excuse me. Tickle. Okay. Okay. So again, you can always use substitution if you would rearrange each of these to be in slope y-intercept form, but the problem is sometimes the slope will have a fraction, and then you're setting two things equal with fractions in them. You move the x's to one side, you have to find a common denominator, and so on. But by doing elimination, we don't have to do the fraction until the very end if there's a fraction as your answer. So for elimination, it's important to line up the x's and y's and the number on the right-hand side. So I've already written it that way. The x's are lined up, one under the other. The y's are lined up, and the numbers are lined up on the other side. So that's important, okay? So if I didn't quite give it to you in the right order, you have to kind of switch it around so that the x's, and then the y's, and then the number. All right. I think this is a bad first example, but we'll go with it anyway. I wrote the wrong one down from the page, but we'll go with it. So what do we do for elimination is we want to eliminate either the x or the y. It doesn't matter which one. So let's say we're going to eliminate the x. It doesn't matter. So I'm going to show you a better next example so that'll make a difference which one you pick. So say we pick the x. What we want to do is multiply each equation by a constant, by a number, so that the new number in front of the x is the same. But with the opposite sign. So one's positive and one's negative. Okay. So look here, we've got a 3 and a 4. What could we multiply the equations by so that the number in front of the x, ignore everything else, the number in front of the x's is the same number? What could we multiply the first equation by? 4. And the second equation? 3. It's kind of like finding a common denominator. You'd say, what's the common denominator between 3 and 4? It would be 12. So you would multiply the first equation by 4 to make that 3x minus 4y, to make the 3 into a 12. And the second equation, what could we multiply by? A 3. That would also make it a 12. But what did I say? They have to be the opposite.
So negative 3?
Right. So instead of 3, do it negative 3. That'll make them both 12s, but one will be a positive and one will be a negative. And it's important to multiply all of them. I started with a hard question. I don't know why I did that.
You can choose either one to make negative.
You can choose either one to be negative, but you're going to add them together, so it's more normal to say 12 minus 12 is 0 than to say minus 12 plus 12 is 0. So I usually put the minus on the bottom. If they're already opposite signs, then you don't need to change any of the signs, right? Okay, so we multiply this through. So we would have 12x, 4 times 4, 16y, 4 times 12, 48. That's the first equation. The second equation, minus 3 times 4 is minus 12. Negative 3 times negative 3, plus 9. Negative 3 times 6, negative 18. Then we add them together. So what do we get when we add them together? 12 minus 12? 0. We eliminated the x's, because that was the whole point of multiplying them, was to get rid of the x's. We wanted to eliminate it, so it's gone. Minus 16 plus 9. Minus 7y. And 48 and 18, 66. Terrible first example. Look at the numbers. So now what's y? We have a new equation, so now we would solve for y. Y equals negative 66 over negative 7. That doesn't reduce, so that's the y value. Yeah. Then we plug it into which equation? Does it matter? Either one. Same step as the last type. You find one of them, plug it in to solve for the other. So we have two equations, so we're going to plug this in, plug into either equation to solve for x. So we have y is 66 over 7, and let's say 3x minus 4y equals negative 12, or 4x minus 3y equals 6. Which one do you like better? I like the bottom one, without the minus 12, with the 6 instead. But whatever one you want is okay. I kind of like this one better, so I'll plug it into that. So 66 over 7, 4x equals, so we need to do 66 times 3. 198. 198 over 7. Now what? So a good example that it's hard and has everything in it that you could possibly want in a question. So now what? Common denominator, that 6 is like it's over 1, so we're going to multiply by 7 over 7. Yeah, big numbers. I wouldn't do this to you on a test for sure. 198 plus 42. 240?
Yeah.
Oh yeah, 240, good. 240 over 7. Now what? Divide by 4, which is cross multiply. Don't think divide by 4, think cross multiply, right? Because you want that 4 to go down with the 7. So x would be 240 over 28. Does that reduce? It does. I think by 4. 4 goes into 24 and 4 goes into 28. 4 goes into 24 6 times, and 4 goes into 28 7, and that would be it. There. Okay, what's our intersection point? $60 over 7 and 66 over 7. xy. So that seemed longer. I mean, the substitution example I gave you worked really nice, but this one didn't. But we'll give you another one. Okay, so here it is. We want to choose to eliminate either the x or the y. Now, in the last example I just chose for you, I just said x. I didn't give you any reason why I chose x. And it was because in the first example it didn't matter, they were both going to be the same difficulty level. But I knew that by looking at it. If I wanted to eliminate the x, what do I have to multiply each equation by? What do I multiply the top by? 5 to make it a 10, and the bottom by 2, but actually negative 2 to make it a negative 10. Now what if I wanted to eliminate the y? Which is not doing anything. So, right, multiplying by 1 isn't anything. What do we multiply the bottom one by? 3. They're already opposite sign. I can leave the top equation alone and multiply the bottom one just by 3, and that will eliminate the y. Do you see that that's easier? You could still eliminate the x, and you will get the same answer, but to eliminate the x, what did we need to do? The top one by 5, the bottom one by 2, that's 2 equations, and negative, and then do it. So, I'm going to choose to eliminate the y. And to do that, I'm going to multiply the first equation by nothing, the second equation by 3. But make sure that you actually multiply everything in that equation by 3. So the first equation I'm not changing, so let's just write it down. That's equation 1. Equation 2, I'm going to multiply everything by 3. So 5 times 3, y, just 1 times 3, and 2 times 3. There they are. And then we add them together. So what do we get? 2 plus 15 is 17x. These cancel, which is the elimination part. And 6 and 6, 12. So x equals 12 over 17. Okay? So now we need to plug that in. And whether you did it substitution or this method, if your answers are fractions, they're still fractions because you'll get the same answer, right? With if you rearrange these, you would have started with a fraction in it. Now we're just ending with a fraction. So we have our x, we need to find y. How do we find y? Plug x into either equation. Doesn't matter which one. Which one do you like better? There's a definite choice here. There's a logical choice and a not a good choice. What are we solving for, x or y? We're solving for y, so we want y equals something. Which is going to be the easier equation to solve for y? Yeah, the one that there's nothing in front of the y. So let's go into this one. X equals 12 over 17. So 5 times 12 over 17 plus y equals 2. 12 times 5? 60. Common denominator? $17. 17 times 2. Um, 26. Negative 26. Okay, so for this next one, let's write it as a question. So, given two x minus 3y equals negative 11, and x minus y equals negative 4. Okay, so 2x minus 3y equals negative 11, and x minus y equals negative 4. Find the x and y intercepts, find the point of intersection, and graph.
So what we did before, when we found the solution, was that the intersection?
Right, yeah, so what we were doing was just finding the intersection points, the other ones.
Never found the intercept at all?
No. Okay, so to do this question, we're going to do the intercepts first. So let's give the equations a name, so every time let's call one 1 and one 2, okay? So let's take 1, and we'll find the x and y intercepts for that. So what we want to end up with is 2 points, one with 0 in each, right? That's how we would answer that question, and that's what I'd be looking for the intercepts. I'd be looking for your points. So this first one is which intercept? When x is 0, it's the y-intercept. So the y-intercept, we're going to let x equal 0. So 2 times 0 minus 3y equals negative 11. 11 over 3. When they're in this form, this linear form, there's not much rearranging to do. When you plug 0 in, you don't have to move things around. You just have to divide by whatever's in front of that. Because this disappears. 2 times 0 is 0, that's gone. X-intercept. Let y equal 0, and it's just as easy. So 2x minus 3 times 0. So that's gone. 2x equals negative 11. Okay. And I wrote them into the points, or you could write them at the bottom into points, whichever way you want to do it. Can we round this first fraction off? What's that equal to? How many times does 3 go into 11? 3 times with how much left over? Can we put it as a decimal?
No.
No, because it goes 6, right? You'd be rounding it off. What about this one? Over 2? There's always a 0.5, so it's okay. This would be in negative 5.5. So you could write that one as a decimal if you wanted to. But you sort of need to know where they are just to be able to graph them in the right place on the graph. Okay, equation 2. Again, we want the x and the y-intercepts for those. let x equal 0. Minus y equals minus 4, you change the signs or divide by negative 1. X-intercept. Negative 4. So there's the points. That's enough to graph them, but they will cross, and we're asked for that point where they cross. If you're not asked for the intersection point, then you would just plot these and hope that your intersection point is sort of in the right place, right? But otherwise, you would just plot these points. And that's what we did in the section before, was just graph them. So now we want to find the intersection point. So to find the intersection point, we're going to use elimination. All right, so we have our choice, whether we're going to eliminate the x and make those both the same number, or the y. I think it doesn't matter here. Why? What would you do if you want to eliminate the x? You want them both to have a 2 in front, so you multiply the second one by 2. What about the y? You want them both to have the first 3 in front, so you'd multiply the second one by 3. So either will work. If half of you chose to eliminate the x, then you would solve for y and then plug it in. But you'd get the same answer, and the other half would solve for x and plug in if they eliminate the y. So let's eliminate x. So if we want the x's to be the same, we would multiply, the first one I'm going to leave alone, the second one I'm going to multiply by 2, but it has to be the opposite sign, so negative 2. So that's negative 2x. Negative 2 times negative 1 plus 2. Negative 2 times negative 4 plus 8. Add them together. So these eliminate, they cancel. Minus 3 plus 2. Minus 1. Minus 11 plus 8. Minus 3. So what's y? Divide by negative 1, so y is 3. Worked out better, it's not a fraction. Now what do we do with the y value?
We put it into one of the equations.
Put it into either equation. So to find x, plug y into either equation. Which equation do we like better this time? I think the second one would be my choice. Okay, so x minus 3 equals negative 4. So when we draw our graph with our intercepts, that's what the intersection point should look like. Okay. I just rewrote the intersection points because they're on the other page, so I couldn't see them. Okay, so what are x values? The x values are the first number, so what do they range between? This is what did we decide that was, 5.5? We have a negative 4, and what's the intersection point? Negative 1. So we only need the negative side of the axis, really. What are the Y values? They're all positive? Yeah. Okay, so we need to go down to -5. We'll go to -6. And the Y values, 11 over 3, we said that's around 3.6 or 3.7. We've a 4 and a 3, so let's go up to 4. Okay. So line 1, 11 over 3 is the Y value, 123.6. And 12345.5. And that line is 2x minus 3y equals -11. I'll just label it. Okay, the second line, 0, 4. And 1, 2, 3, 4. Oh. And does the intersection point look right? -1, 3, yeah, about right. There. So I've labeled the lines, I've written in all the important points. And because I measured with the ruler, the tick marks were equally spaced, it should usually end up in the right spot, whether you use graph paper or not. You do not need to use graph paper, but if you like that better, then they're already equally spaced for you, right? So you just don't need to measure them out. Okay, so that is all of section 2.1, 2.2, 2.3, which is due next Monday. We're starting the next section that's not on the test on Friday and Monday, right? But I'm not going to put those on this test. They'll be on the 4th test, okay? So